We're going to start this lesson off by graphing quadratic functions in vertex form. And so my vertex form of a quadratic is f of x equals a times x minus h quantity squared plus k. This should look vaguely familiar because these are a lot of the same variables that we were using with transformations. A was my stretch and compress. My h was my horizontal shifts, and then K was my vertical shifts. So if you remember from that lesson, we said inside opposite, outside same. My vertex is inside opposite, so instead of this being a minus H, it is a positive H, and then outside K, or sorry, outside same, so this plus K is a positive K. So why do we call this a vertex form? Because it gives me my vertex. And then we have an axis of symmetry, which I really didn't talk about very much in the last lesson. So let me get this sheet here. Your axis of symmetry here behaves a lot like when we had y-axis symmetry. Wherever that line of symmetry is, it goes through that vertex, and then the left side is going to mirror the right side of that axis of symmetry. So your axis of symmetry here is x equals your x coordinate. So x equals h. So why do we call this vertex form? Because it is nice and it gives me my vertex just by looking at this equation. Now I have a note up here that I'm going to keep referring to this as vertex form because I had no idea it was called anything else. Until I looked at this homework, but the homework actually calls this a times x minus h quantity squared plus k, this right here, standard form. So just kind of a heads up and a little bit of a help whenever you get to your homework that I'm referring to it as vertex, but the book calls it standard. So let's get into our example. Example 1 says for each quadratic equation, f of x equals, find the following and then graph. So I'm actually going to rewrite this equation a little bit, and I'm not 100% sure why they give it to us in this form. I wrote it this way because this is one of your problems in your homework, writes it in a little bit of a funky way, but this would be the same as f of x equals negative x plus 2 quantity squared. That 9's positive, so plus 9. So this doesn't really ask, does it open up or does it open down? But I do want to make note that because of this minus right here, this parabola is going to open upside down. So this parabola will go concave down like this. Now, the first thing it asks is for the vertex. So my vertex is H, comma K, inside opposite, outside same. So this plus 2 is a negative 2. And then positive 9 is a positive 9. Inside opposite, outside same. So then the axis, let's go actually just go ahead and plot that. So 2, 9 up here. And so it's not concerning that the vertex is so high because we know it's concave down. We know this is the highest point. So that kind of makes sense. And then the axis of symmetry is x equals your x coordinate here. So x equals, in this case, negative 2. Now, I can't remember if your homework asked you to put a dashed line for your axis of symmetry. It might, I can't remember if it's this homework or homework from another class, but you need to go through, maybe not on the homework, but when you're putting that axis of symmetry, you're going to represent that with a dashed line. That dashed line kind of lets you know it's imaginary. It's not really there, but we're putting that in there. So we're going to put it with a dashed line and then label that as x equals negative 2. So now we need to find the x-intercepts. So from that first page, it says to find the x-intercepts, we're going to let y or f of x equals 0 and then solve for x. We have 3 ways to solve for x by factoring, quadratic formula, and square root property. When I am in vertex form, the square root method is going to be the best way. We did this in lesson 4. I want to get this squared component by itself. Now, because this is negative, I'm actually going to want to move this over to the other side. It will save 1 step. So I'm going to add that entire thing over. So now I have x plus 2 quantity squared equals 9. And now that I have that squared component by itself, the opposite of squaring is to take the square root. So I'm going to take the square root of both sides. And so I get x plus 2 because my square root and square cancel. And that is going to equal, and then be careful here. Because this is a quadratic, we have x squared. I have 2 answers. So it's not just positive 3, but plus or minus 3. Now I can continue on here. Oh, no, I'm not done. I need to solve for x. So subtract that 2 over. So I get x equals -2 plus or minus 3. So because I have 2 whole numbers here, I can go ahead and get my 2 solutions. The first one is when I have 2 plus 3, so that's going to give me 1. The second one is -2 minus 3 to give me -5. Now, I'm pretty sure in my math lab, all it wants to know, find the x-intercepts, and you'll put x equals 1, comma, -5. So answer my math lab questions, whatever form they want, but for me, I like ordered pairs. So my x-intercepts are at the ordered pair 1, comma, 0 and -5, comma, 0. Now I need y-intercepts, and y-intercepts are the opposite. We're now going to let x equal 0 and solve for y or f of x. So I'm going to have y equals -0 plus 2 squared plus 9. Plugging in a 0 for this x, and now I'll just evaluate this. So we're going to have negative. We're going to just have 2 in here. 2 squared is 4. That negative tags on to it, so it's -4 plus 9. And that's going to equal 5. So again, my math lab, I think, just says y-intercepts, y equals, and you're just putting in 5. But for me, I like ordered pairs. So this is 0, comma, 5. Now, probably should have been plotting these the entire time. So, my bad. We've plotted the vertex, we've plotted the axis of symmetry. So let's go back and let's plot these x-intercepts real quick. We're at 1, 0 and -5, 0. Now, what's nice about this axis of symmetry is we can check our answers. From that axis of symmetry, we are 1, 2, 3 units away, and we are 1, 2, 3 units away. So those are more than likely correct because they're equal distance for my axis of symmetry. So now I'm going to plot my y-intercept at 0, 5. And typically I like 5 points on my graph, and I only have 4. So I can add a 5th point by using this axis of symmetry with my y-intercept. If this y-intercept is 2 units away, I'm going to go 1, 2 units in the opposite direction, and that gives me my 5th point right there. So do remember these need to be U-shaped. And so you want to make it as curved as possible. Make sure it's not a V for absolute value, right? So we want to make sure that that is as curved as we can kind of get that right there. And here is my quadratic. So now I need to state the domain of this. So we haven't done this in a couple sections. We're going to go left to right. As we go from the left to the right, the first thing I hit is that arrow, and the last thing I hit is also an arrow. So my domain is negative infinity to infinity. And spoiler alert, your domain for all of these will be all real numbers. Your range is going to change though. As you go from the bottom to the top, the first thing we hit are arrows. So that is negative infinity. And then as we keep going up, here's the top of my graph, and that y value at that is at 9. And because 9 is included, it will get a bracket. Now, example 2 is kind of just a bonus. And all we need to do here is find the x-intercept of this equation here. So I can see it is in vertex form. If I needed the vertex, that would be 3, 2, inside opposite, outside same. So this would change to a positive 3 and then comma 2. But I just need my x-intercept. So to find that x-intercept, we're going to let y, or f of x, equals 0 and solve for x. So I have 0 equals x plus 3 quantity squared plus 2. And we have 3 ways of solving. Factoring, quadratic formula, or square root. Square root method is the best for vertex form. So what I need to do is get this x squared component by itself. Now before up here, because my x squared component was negative, I moved that over. This time, because it's positive, I'm going to move this 2 over instead. So now I have negative 2 equals x plus 3 quantity squared. Now that I have that squared component by itself, I'm going to take the square root of both of those. And right here, I get an imaginary answer since I have that negative under that radical. So if I am finding the x-intercepts, if I get an imaginary answers means I have no x-intercept. So no x-intercepts. And I guess we just kind of talked about what that looks like, right? If I was to graph it, it says, what does the graph of example 2 look like? If I was to graph, because this is positive, that means it's opening up, and we already said that the vertex here was 3, 2. So 3, 2 is over here in quadrant 1. My parabola is somewhere up here at 3, 2, and it faces up because A is positive. So what does this graph look like right here? Well, it doesn't touch the x-axis.